Hello and welcome to tonight's lecture about air pollution. We're in lecture 3. We are 3/4 of the way done here with the atmosphere. So we've learned a lot about what's in the atmosphere, how the atmosphere is organized by layer, how we measure some of the important aspects of the atmosphere like air pressure. Today we're going to find out about air pollution and sort of what we need to do to take care of it, what we've already done to prevent air pollution from happening, and what air pollution is. So let's get started. It's important to think first about what air pollution is. Okay, so air pollution is the contamination of the atmosphere by wastes from sources like industrial burning and automobile exhausts. Okay, no surprise those two are listed first because they are among the two most common producers of air pollution. So the substances that pollute the air can be in the form of solids, liquids, and gases. We're probably going to see gases be the most common pollutants. Most air pollution is a result of human activities, but some pollutants are natural, right? We've talked about volcanic eruptions in the past, pollen, you might know. All these things that necessarily we don't want in the atmosphere are considered air pollution, okay? That word contamination just signifying that it's unwanted, right, in the atmosphere. So there's two kinds of pollutants. There's two sort of categories. Excuse me. A primary pollutant is a pollutant that is put directly into the atmosphere by human or natural activity. So soot from smoke. Okay, so you burn coal, you burn fossil fuels, and you put that soot in the air directly. Secondary pollutant is a pollutant that forms in the atmosphere by a chemical reaction with primary air pollutants, natural components in the air, or both. So an example of this would be ground level ozone, aka, we're going to hear about this soon, smog. Okay, so smog is what we call ozone, right? Same thing as in the ozone layer, right? The O3. We discussed that before. But when this is not in the upper parts of the stratosphere where it should be, we call it smog, and it has some negative effects. Ground level ozone forms, again, when the emission from cars react with UV rays from the sun and then mix with the oxygen in the atmosphere. Okay, so it does some of the same stuff it does up in the stratosphere, but has some negative effects. Again, we'll see more about this later. So again, secondary pollutants are something goes in the atmosphere, doesn't necessarily cause any problems, but then has a reaction to form a pollutant. So the most primary pollutants are listed here on this chart. Electricity production, okay, so it's most often burning fossil fuels here. You can see sulfur oxides here in this column there, and these VOCs here, along with nitrogen oxides. These are common pollutants that go along with, or the ingredients of fossil fuels like coal, gasoline, and natural gas. So electricity production, right? We're burning less coal than we have in the past here in the United States, but worldwide, burning fossil fuels still is a common way to produce electricity. Industry, when you think about factories, you think about the production of goods. That's what that is right there, okay? And with VOCs, these volatile organic compounds being the chief one there. So transportation, if you look at that, so that would be driving a car. Far and away, carbon monoxide and carbon is what is put into the atmosphere. Okay, so we're going to learn more about greenhouse gases and things like that, but this one here is certainly a greenhouse gas. So cars are a major source of primary pollutants, and other sources, right? So you might consider fires, you might consider heating of homes, and a few other sources here are kind of lumped into the other category. But it looks like electricity production and transportation are the top two. Okay, so it looks like the top part of this slide is being cut off. I apologize for that. I'm trying to figure out what's going on, but we'll just keep going and pushing ahead. So the sources of these primary pollutants, again, kind of broken down to it. So household cleaning products and household products, power plants, and motor vehicles are sources of primary pollutants, right? Because remember, primary pollutants means pollutants that are put directly into the atmosphere, directly into the air. So carbon monoxide, nitrogen oxide, sulfur dioxide, and chemicals called VOCs. Vehicles and coal burning power plants are the major source of the nitrogen oxide emissions, right? Because, again, those are chemicals found in fossil fuels. Power plants, refineries, right, is where you take a crude oil or a crude fossil fuel and you refine it, you kind of cook it down to something that's useful. And then metal smelters contribute much of the sulfur dioxide emissions. So these big industrial plants, smokestacks, think, just sort of the industrial complex is where a lot of these pollutants come from. Vehicles and gas stations make up most of the human-made emissions of VOCs, of these volatile compounds. Particulate matter, remember those little particles that can kind of float up in the atmosphere, can also pollute the air and are usually divided into fine and coarse particles. So fine, meaning kind of like smaller, enter the air from fuel burned by vehicles and coal-burning power plants. And then the coarse particles, which are a little rougher, a little larger, cement plants, mining operations, incinerators, wood-burning fireplaces, fields, and roads. So, one is sort of that more of a fine dust, more of a fine soot, right? Something that is easily going to be carried right up high in the atmosphere, versus these coarse particles, which are going to be a little bit larger and fall to the ground more easily. So we've been dealing with air pollution for quite a while. Whenever something burns, pollutants enter the air, right? So how long have we been burning things? Quite a while, right? So in all the way back in 1273, King Edward ordered that burning a particularly kind of dirty coal called sea coal was illegal. So, maybe that's the first example of a law being passed or legislation being passed, which is designed to prevent pollution. We've got worse air quality today because of modern industrial societies, right? Think about the Industrial Revolution and all that, the famous stories of England and the air quality there getting really bad. Mainly because we burn lots of fossil fuels. Most air pollution in urban areas comes from vehicles, right? So we've got a lot of people, a lot of cars, and also a lot of industry to support those people. So it's really skyrocketed, but it's not new, right? We've been burning coal, peat moss, wood to stay warm for a long, long time. Let's talk about motor vehicle emissions, right? Because this is maybe where all of us have experienced and all of us know a lot about cars and how they work. Almost 1/3 of all of our air pollution comes from gasoline burned by vehicles. This is not like opinion here. This is fact produced by government after government and the Department of Transportation and EPA. According to the U.S. Department of Transportation, Americans drove their vehicles. This is 10 years old now, but 3 trillion miles in 2010. And I can update and report that number. So as of 2018, which is a little newer, we're up to 3.225 trillion. Okay, so we've gone up a little bit in the last 10 years. Not a drastic amount. I mean, it's a lot. It's 225 billion. But that's a lot of miles, right, guys? So I mean, 300 trillion miles just look at the number is pretty staggering. Right? We've got 100,000 million. Oh no, not even done. All right, it's a big number. Okay, so 300 trillion miles in a year. So roughly 90% of that mileage was driven by passenger and other light duty vehicles. So this is just mom driving you to school. This is not trucks. It's only 10% that make trucks and buses and these big cars. So we're talking about regular passenger vehicles. Okay, so 1970 comes along in the United States, passes a law called the Clean Air Act. All right, so and it was again strengthened in 1990 by I believe George Bush, which gives the Environmental Protection Agency, or the EPA, the authority to regulate vehicle emissions in the United States. The word regulate just means sort of set limits, make recommendations, and whatnot. So the EPA required the gradual elimination of lead in gasoline, right? So you've heard of unleaded gasoline, right? That's what just about all gasoline you see at regular gas stations is. Decreasing lead pollution by more than 90% in the United States. So this is 1970, right? So I want you to think back to the video we watched about the clean room, about the gentleman who kind of discovered how much lead poisoning was being spread throughout the country. That was like 40 something years before this in the 1930s. So it took a long time for the Clean Air Act to pass, or really for us to say, hey, maybe we should stop putting lead in the air too. And it took a while to do that. So unleaded gasoline is the law of the land now because of the Clean Air Act. So we've also, in addition, catalytic converters are required now in all automobiles. They clean exhaust gases of pollutants. So it's sort of like if you think about your car, there's a rough drawing of a car. Your car has this little tailpipe, right? So what the catalytic converter does is that actually, if it could zoom in on the tailpipe, it's another little part right there, kind of shaded there, kind of catches some of the pollutants before they exit the car, before they exit the exhaust. So this is another thing that was required to put in cars. Cars today still have them, which convert some of those pollutants to less harmful exhaust. Let's talk about industrial air pollution. So these are companies and factories here that produce air pollution. So many industries and power plants that generate electricity, again, must burn fuel. They have to get energy from somewhere, and they usually burn fossil fuel. Okay, so back in the day, in the Industrial Revolution, and even in maybe your parents' era, it was a lot of coal. Now it's a little bit more natural gas, but they need that to get energy, right? Burning fossil fuels releases huge quantities of something called sulfur dioxide and nitrogen oxide in the air. Power plants that produce electricity emit at least 2/3 of all sulfur dioxide and more than 1/3 of all nitrogen oxides that pollute the air. So of all of these two pollutants, it comes from these two sources. It comes from factories burning fossil fuel to produce energy for making something, or sometimes simply just for energy, for our electricity usage. Some industries also produce these VOCs, which are chemical compounds that form toxic fumes. So that the VOC again is not good. Dry cleaning, oil refineries, and chemical manufacturing plants, furniture refinishers, and automobile shops all contribute to VOCs in the air. So VOCs are just other really harmful to humans and organisms, chemicals in the air. So when people use some of the products that contain VOCs, like some of the products we saw before, like cleaning products, refining products, even things like paint stripping, you can think about paint thinner, things like that. All of that contributes to VOCs. And then we have more of these VOCs added to the air. So, sometimes we need to use these products for our daily lives, but it's still true that they contribute to air pollution. So the Clean Air Act, again, had another requirement for these industries to use something called a scrubber, which is a good name because that's what it does. Scrubbers remove or scrub some of the more harmful substances that would otherwise pollute the air, and they use water. Okay, so a scrubber is a machine that moves gases through a spray of water that dissolves many pollutants. I'll show you an image of that in a minute. Ammonia is an example of a pollutant gas that can be removed from the air by a scrubber. So as those chemicals kind of move through, let's kind of make it like a smokestack. The scrubbers are there to kind of remove some of those chemicals. So it's not going to remove everything, but it's going to keep some of that stuff from getting out into the atmosphere. Another way to do it is with these electrostatic precipitators, are machines used in cement factories and coal-burning power plants to remove dust particles from smokestacks. So this uses electrostatic charge. In one of these electrostatic precipitator, gas containing dust particles is blown through a chamber containing an electric current, right? So the electric charge is transferred to the dust particles, causing them to stick together into the sides of the chamber. So there's that chamber here, the dust is moving up through that way, and the charge on either side causes that dust to stick, right? So if you've ever had, static electricity, or your clothes sort of stick together, or a balloon stick to your hair, that example there, same idea, uses that charge, right? So either a positive charge on that side, maybe a negative charge on that side, to pick up and attract these particles. So to review, a scrubber uses water, and one of these electrostatic precipitators uses electric charge to clean some of this dust as it leaves exhaust in the chamber. Again, here's another image here, another way that industry is regulated here. So the clean gas is released from the chamber and concentrated dust particles that can be collected and removed. So here's sort of an example of a filter here. So these electrostatic precipitators remove more than 20 million tons of ash generated by coal burning power plants from the year. So the gas kind of comes in the chamber here, all right, heads up, and through here goes through that filter, that electrostatically charged filter, right? So it's either got a positive charge or an opposite charge to the gas going through, and then the gas that has been cleaned of some of these dust particles heads out, and a little water is also added to give that thing a charge here, and then the dirty water from the process is sent out through here. So this example, you can have a scrubber and a filter in the same thing, essentially how it works. So let's quickly talk about what smog is. We referenced it before, but let's define it here. So smog is urban, so city, air pollution composed of a mixture of smoke and fog. Smog, smoke, fog, produced from industrial pollutants and burning fuels. So smog results from chemical reactions that involve sunlight, air, and automobile exhaust, and ozone, our old friend ozone, okay? Pollutants released by vehicles and industries are the main cause of smog. So, cities like Los Angeles are famous for it because they've got a ton of people. In Los Angeles, everyone drives a car. There's very little public transportation, so got a lot of cars in a big city like that. So you have a lot of smog. They're kind of famous for it. Here's a quick just sort of diagram on how it works. So the automobile exhaust gets contributed, and it reacts with the sunlight. So back to LA, right? It's a sunny, warm city, a lot of sun, a lot of smog, a lot of exhaust. So the exhaust reacts when it hits sunlight. So those UV rays react with the ozone and the exhaust, and then it forms this sort of cloud here. And what the cloud does is actually traps in some of that heat and compounds some of the issues here. So smog is not good. It kind of forms like a dirty fog layer. The result of this is something actually called a temperature inversion. So when you have smog, one of these temperature inversion can result. So a temperature inversion is the atmospheric condition in which warm air traps cool air near the Earth's surface, right? So if we think about like the layers of the Earth, like there's the Earth, if you have a layer of warm air, you can actually trap in that cooler air below it. So it's an inversion because it's kind of the opposite of what we think. Usually you expect that cool air to warm up and rise, but it's kind of trapped here and prevented. So the warm air above keeps the cooler air at the surface from moving on upward. So pollutants actually get trapped below her, okay? So if a city's in a valley, like again Los Angeles is, it has a greater chance of experiencing temperature inversion. So Los Angeles has got mountains on three sides, often has temperature inversions because they've got all this air pollution here, right? They've got a layer of smog. The smog the warmer air kind of traps and keeps those pollutants down low by the people. So it's not good. So again, what a temperature inversion is where warm air traps cooler air near the Earth's surface. It's not good. All right, so here's a nice little image of it. You got the sun here. You've got escaping pollutants heading up. You've got cooler air lower here, and you've got your warm layer here. So the warm layer is trapping the cooler air and the pollutants down below, so you get this lovely layer of smog and pollution down a little bit lower here. So far in this lecture, you've learned about what air pollution is, what some of the main contributors are, which is industry, but mostly automobiles, right? Automobiles are the number one culprit. You've learned a little bit about how the United States has passed laws to limit some of this pollution, and just toward the end here, we learned a little bit about some of the technology used to clean up this pollution, right, with scrubbers and the electrostatic scrubbers as well. So, look over this lecture, make sure you know your stuff. You may or may not have use of these notes on some test or quiz, so study, and I hope to talk to you soon. See you soon, and go Bills.